Good to see all of us. Welcome to our class today, where we are going to discuss experimental design. Like we had agreed the last time we were together, we met and we discussed, let me put this off. We met and we were discussing quantitative research designs. So last time we met, we started looking at quantitative research designs or quantitative research methods design. And we talked about what is a design, and we explained and said quantitative designs are those designs or are those plans that will enable a researcher to collect numerical data. Because when you talk about quantitative, then you are talking about the type of research that will enable you to collect numerical data. And remember, we said when we say to collect numerical data, it does not mean that it is data that you have only counted. It is the variable that you can convert to numbers, variables you can convert to numerical. And that is why, if we go back to the same example we used, if I asked you, why did you choose to study in University X? You will give your reasons. If you are 10 of us, you give your reasons and the researcher will tally. Maybe because of quality, that is point number one. So we tally how many said quality. Maybe because of the structure, we again tally how many said. And what we have done is that we have converted that variable called, choice of the university to numerical data. And as we were discussing the quantitative research designs, we said there are normally two types. They are the experimental ones and the non-experimental ones. So we have those two types of quantitative design. And we discussed the non-experimental designs. And those ones are two. So we have survey, which can either be correlational, it can be cross-sectional, or it can be longitudinal. So that is survey. And normally survey is that type of design that you collect data from a large population for the researcher to understand the perception, the attitude, generally the thinking of a population, so that they can generalize it to the wider population. When we'll be talking about data analysis, we'll be talking about when do you generalize findings to the wider population. We then talked about ex post design or ex post factor design. And we said when we say ex post, you are saying after the fact. So this design is the one you want to find out what may have brought in the change. So you are going backwards. The fact has already happened. So you are going backwards to ask yourself what may have brought in. And that is why some people normally confuse it with the experimental. But because here you don't manipulate any variable, you go back. And if you remember, if you are in class during lesson 6, we give an example of the doctor. When you go to see a doctor when you are unwell, the doctor normally starts going back. You tell him you have a stomachache from yesterday, and then you start finding out what had you eaten. Is there a history of people with stomachache in your family? Had you had another stomachache before? etc. They go back. It is a retrospective design, and that is what ex post factor is. The government has introduced a new book, a new teaching and learning material. So I go to the schools to find out, has the book brought in better results than the former one? So you are going after the fact. That is why it is called ex post factor, after the fact. And those are the two non-experimental designs that we talked about. And today we are going to discuss experimental designs. And we are going to look at both true and quasi. What differentiates the two designs? What differentiates between true and quasi-experimental? So, many a times as we discuss, as we talk as human beings, we use the word causality, or we use the word cause many times. You will hear somebody saying, I normally don't take milk. Anytime I take milk, it causes my stomach will bloat. So taking milk causes bloating, or anytime I eat greens, I will feel like I have an ulcer, or I'll get, it will cause heartburn. And that is, we carelessly use the term causing in our day-to-day conversation, but we would say that is allowed. In our day-to-day conversation, that is okay. But as researchers, is it true that drinking milk caused the bloating? Is it true that eating greens caused the heartburn? Is it true? And therefore, in research, we need to be very careful as researchers when we are using the term cause. This is a very strong word that most of the time, even in our day-to-day, on many of our students, even when you are doing your thesis and dissertation, many a times many do not have the desire to do a research on causality, not because it is hard, not because it can't be done, but you'll be looking at why is it not a very, it is not a very, it's not a design that many students find useful, in quotes, to use in their study. What could be the issue? What could be the issue that many students don't take it or don't feel like it is a design that they need to use? Yet, it is a quantitative design. It is a design that we use in social sciences. So in research, we only use the word cause. That means X causes Y. Like if I say that it is greens that have caused the heartburn, only when you are sure that you have removed all other factors that may confound this assertion. If I want to tell you to stop taking soda, and I'm telling you soda causes weight gain, have I removed all other factors that may have brought about weight gain so that I am only left with soda? What about if you have been eating a kilo of meat, you have been eating carbohydrates, you have been taking soda? How confident would I be to tell you that soda causes weight gain? And that is why many a times students end up working on what do we call them? Topics or problems that you deal with influence, not because experimental cannot be done, but because of eliminating all the other factors that may confound this assertion. But does it mean it is difficult to be done? No, it is not difficult. It's only that I think even as we teach, as lecturers who teach research methods, we normally instill in our students that if you are social science, then experimental is not for you, And I think also we carry what we did in basic education or secondary school. We were doing the experiments in the lab. We were trying to prepare oxygen using manganese for oxide and hydrogen peroxide, if at all you did chemistry. I think that is the mentality that we have, which is wrong, because this is a design that is easily used by a social science. But of course, we know, as we said in our last lesson, that the design you choose is determined by the problem, the problem of your research. So when you want to talk about causality, X causes Y, we use experimental designs. That is where they come in. And that is why experimental is treated like a special design, because this is the only design where you can confidently say that X causes Y, as long as you have removed all the other factors that may confound this assertion. And experimental designs, you have randomly assigned and randomly selected, and we'll be discussing about that. So experimental designs attempts to study causality. Now, when we talk about causality, we are talking about cause and effect relationship. There is a cause. When you manipulate X, there is a change that you occur on the outcome. That is what we call causality, the cause and effect, that a change cannot occur unless there is manipulation of X, which in our case is the independent variable. So the main aim of experimental research or experimental studies is to discover causal relationships between variables. And by causal relationship, it means X causes Y, X causes Y. And how would you say that X causes Y? It is by manipulating X, and in this case, X is clear independent variable, to see the change it will have or the effect it will have on Y, which is the dependent variable. And that is why Criswell and Criswell 2023 says, importantly, an experiment isolates the effects of this manipulation by holding all other variables constant. So you are eliminating all the other variables that can confound that experiment. And this is what we call controlling for extraneous variables. And even when we discussed extraneous variables, and I think in our lesson 4, we talked about an extraneous variable as that variable that must be controlled because it confounds the relationship between primary IV and DV. So you must identify an extraneous variable and you must control for it. That means you must remove its effect. You must remove its effect. So in experimental, this is a must. You must identify all extraneous variables that may confound the issue of causality so that you are only left, you have eliminated anything else that may confound the relationship between X and Y, so that now you are only left with X to see the effect on Y. So this causality is only determined once you have removed all the extraneous variables, what we call controlling for. When you are conducting an experimental study, sorry, that word experimental is written wrongly. So when you are conducting an experimental study, there are a few things that you need to note. Number one, ensure you have two homogeneous groups. This means that there are groups that have similar characteristics. You cannot be doing an experiment of 50 years and below. You want to tell them to stop drinking soda with people who are 15 years and below. The groups must be homogeneous. We have not said they should be the same because you cannot have two people having the same characteristic, but they should have similar characteristics. If I want to deal with people who are 50 and 60, then the two groups must have people who are 50 and 60. If I am dealing with females, then it will be females and females with similar characteristics. You cannot pick a group from maybe like a slum area and you're comparing it with a group that is coming from a higher socioeconomic status. The homogeneity is very key. And these two groups, one is called control. That is the group that is not given the treatment, and the other one is called experimental. This is the group that is given the treatment. And the other point to note is these groups need to be sufficiently large. And of course, we know every word we use in research needs to be qualified. Remember, when we talk about quantitative research, we normally say that the sample should be more than 30 because of the central limit theorem. Okay, so that is where we are borrowing this from. But there are some researchers who will say for the experimental group, it needs to be more than 40. So what are we saying? That the group that you are going to use must be 30 plus. So you cannot do an experimental study of 10 people. And any quantitative research we know, because of the statistics, you cannot carry out statistics on a group that does not fit the central limit theorem. So that one is key, the issue of homogeneity of groups and also the issue of the number, Number two, you need to determine the inclusion and exclusion criteria. That means you need to describe how you are going to do your recruitment. How are you recruiting the participants? And that is again borrowed from what we have said in point one. What you select, the people that you are recruiting, should share certain characteristics. And that is why you would say, my group A and B have the following characteristics, and that is why they fit to be in the experimental or in the control group. You'll be discussing how you do that. So the inclusion and exclusion criteria needs to be stated very clearly. Why did you leave out this group and you picked this one, this particular category of people and not this one? That one is important. Number three, once you have identified your homogeneous groups, you have recruited them, you have stated your criteria of selection, inclusion, and exclusion, then you need to give them treatment, the experimental group. Then you compare the effects of the treatment on the group that was not given the treatment. So point number three says the effects of the treatment, or what we call an intervention, are ascertained by comparing the behavior of the treatment or the experimental group with that of the control. That means that if I had a group of 50-50, women between 50 and 60 years, I want them to stop taking soda because soda causes weight gain. So I have removed all the other factors that may confound this relationship. Then I will need to do a pretest. Then I give my experimental group soda from maybe date 1 of August up to date 31. Then my control group, I will not give them soda at all. Maybe they'll just be taking water. And then I compare the two. Then I compared the two by taking a post test. If the group that was given soda will have changed their weight even by 1, then it means now I can confidently say that stop taking soda because soda causes weight gain. Number 4, the issue of randomization. And this randomization is what differentiates experimental from survey. And this is also what differentiates between true and quasi-experimental. Now, what does randomization mean? Randomization means that the people who will be assigned to the experimental and control group should not be handpicked. They should not be handpicked, that I look at you, I tell you, you go to this one. I look at you, I tell you, you need to go here. They should be randomly selected and randomly assigned. And of course, we know when we talk about quantitative research, we normally say, even as you do your sampling, it needs to be random so that it is a representation of the population. So randomization is very key in experimental design. So if I have a group of 100, maybe I'll just give number 1, you go to experimental, number 2 control, number 3 experimental, randomly, but you don't select. You don't handpick that you need to go here, you need to stay here, no, it should be randomly selected and then randomly assigned. And nobody should know. That is also another important thing. Nobody should know that they are in the experimental or in the control group. Nobody should know where they are. It is only you as a researcher who knows. And that is why when we start talking about threats to validity of experimental design, we will be looking at some of the things that you do so that you reduce the threats. So those 4 points are very important to note. Then another one, they actually 6, not 4. Be aware of spurious relationship. Now, spurious relationship or spurious correlation is a state where you may misrepresent causality. Spurious relationship or correlation means two variables are statistically related, but they are not causally. There is no causality, but they may be related, but it is not because of cause and effect. It is not because there is cause and effect. That means the presumed cause of this effect is by an unseen or another unconsidered variable. Let me give an example. You normally hear people saying that smoking causes lung cancer. You know, the question is, why do people who don't smoke get lung cancer? So are we sure when we say that smoking causes lung cancer? Of course not. So these two variables, smoking and lung cancer, they are statistically related, but they have no causality. They have no causality. Because if they had, then someone who doesn't smoke should not be getting lung cancer. So that is a spurious relationship, and you must be clear of it. You must be aware of it as you do your experimental study, because it may lie to you that there is causality, yet it is just a relationship. It is just a relationship. And then point number 6, and I think is the last one, all extraneous variables must be controlled. I think we had mentioned that, and we cannot stop mentioning. All extraneous variables in an experimental design must be controlled. And to control means to eliminate or to remove as much as possible the effects of extraneous variables so that they do not threaten the experimental procedure. They do not threaten your assertion that X causes Y. So again, the reason why you control is to ensure that the two groups are as equivalent. Remember, we are not using same because you can't have the same, but you want to ensure that the groups are as equivalent as possible. Now, assume you are doing an experimental. I am doing an experimental study where I want to show the world that it is because I taught, and that is why you have performed well, you know. So I have to ensure that you're only listening to my teaching. You are not reading any textbook. You are not meeting for group discussion. You are not going for tutorial. You are not, it is just teaching. So I have removed all other factors that may bring good performance. So if I'm able to do that, if I'm able to remove any other factor that may bring about good performance. So I have locked you somewhere. I have kept you somewhere. Let me not say locking, because now people might start imagining that for you to do an experimental study, you must be in a locked room, no? So you are somewhere where you have no access to any group discussion, to any textbook, to any whatever. You are only listening to the teaching. Then you do the cut or an exam and you do better than another group, then I can now say it is my teaching that caused the good performance. But as long as I am teaching, but you're also reading, you have your group discussion, you are taking past papers to revise, I can never say that it is teaching that has brought in the good performance. So there are many other factors that would bring you the good performance, and that is what we are calling extraneous variables. So I can only confidently say that teaching brought the good performance if I have been able to remove all extraneous variables so that the groups can be as equivalent. So imagine if you are in an experimental group, but there are people who are going for tuition, so it means whatever we say disadvantaging the others is what is happening to you, because you are only listening to teaching and others are even going for tutorial for remedial teaching. So you remove the extraneous variables so that the groups can be as equivalent as possible. We are all going through the same. we are all going through the same, like the way schools we are uniform, so that students, all of them, are as equivalent as possible. So that is what those 6 points are key to remember. Then it is important to discuss, how do we control for extraneous variables? There are quite a number of things, of ways in which we control. And I have written a number of them in my book. Those who have the copy, I'm sure you can attest to that. If you go to page 71, from page 71, where we have discussed the experimental design. So if you haven't gotten this copy, please make sure you get it through the website. So there are a number of ways in which you control for extraneous variables, but I'll discuss 3. Number 1 is randomization. So that is random selection and random assignment. So the people who go to the control and experimental groups should be as equivalent as possible, because you have randomly selected them and you have randomly assigned them. We are going to give the definition of those 2 terms. The other one in which you control is to remove the variable. To remove means you are eliminating it by removing it from the study. For instance, if I was doing a study where I have both males and females, for instance, and I realize that maybe the having females in this study is going to affect my results or is going to affect my experiment, I may remove the females. I may decide to only use the males. And that means I have removed the variable, so that the other variables that these females would have brought, it is the effect has been eliminated. The other one is matching cases, where randomization is not feasible. The researcher tries as much as possible to match the participants who will be assigned to either experimental or control group. They try as much as possible to match them so that they have similar characteristics. They have that characteristics that they want to measure. What is the difference between true and quasi-experimental design? What is the difference between the two? The difference is randomization. The difference between true and quasi is randomization. We have said that the selection of the participants, the assignment of the participants to either experimental or control group should be random. It should be random. Now, true experimental is where random selection and assignment is feasible, whereas quasi-experimental is where non-random selection and assignment is applied. Now, let me explain. We have 2 types of experiment. Actually, there are 3, but the main ones that we normally talk about is the true and quasi. What differentiates the 2? The true one is normally mainly done by people who are in natural science. For them, they are able to randomly select and randomly assign. When people in the medical field would want to introduce, or they are doing a research on a particular vaccine, for instance, they will have identified the sample that they are going to use. So the sample, again, if it is 100, the 50 who will go to the experimental design, group, are randomly selected and assigned. The group that you go to the control are randomly selected and assigned. It's only that they don't know. And both groups will get similar treatment because there is something we call placebo that we are going to discuss in our next lesson. So true experimental, which is done in labs, is mainly done by people who are in natural science, because they are able to select their sample and they randomly assign them to either experimental or quasi. And even when we are writing the designs, and you will see when we are discussing them, for true, we normally add the capital R to show that randomization is feasible. quasi-experimental is what us as social sciences do. Why are we not able to randomly select and assign? Because we deal with already formed groups. We deal with already formed groups. If I wanted to go to a school and I want to do the effects of a new book, allow me to use the same example, effects of a new or the new teaching and learning material that the government has introduced. When I go to school A, B, C, D, whatever number of schools I'm using, I cannot go and start changing the classes. So what we shall do, we will agree with the teacher that we are working with, for instance, that let class A be the true one and let class B be the control one. You know, one is experimental, the other one, or you have schools. School A will be the experimental and school B will be the control. And I hear even when national exams are being done, that is what National Examinations Council in many countries will do when they are piloting, you know, when they are piloting the exam. So they will have the group that will do the real exam and the group that will not do the real one. So you deal with already formed groups. Already formed groups. You are not the one who randomly select and assign. You go to find out already formed groups. If I wanted to find out, there is a time the government in Kenya was giving women, I think it was called Women Fund, or maybe I can use the Youth Development Fund. So the government was funding the youth so that they start their small businesses. You know, so if I wanted to find out the changes that this fund has brought in, I would already find groups that have already been formed by the youths. They have already formed themselves. These ones are rearing chicken. These ones are rearing cattle. These ones have started their motorcycle business. These ones are doing salon work, you know. So they have already formed themselves. And then I have another group that was not given their own. They were not given the fund. So you compare the two. Has there been a change that was brought about by this particular youth development fund? And that is why when you're doing an experimental study, if you are in social science, you will do the quasi-experimental. You normally use in your title. It will either be effects of, or you have impact of, or you have effectiveness of. Because when you say effect, and you know the word effect and impact, for those who have done M&E, you know, effect and impact. Effect normally looks at the changes that have brought to the beneficiary, but the impact goes beyond the beneficiary. And normally impact is done after a long time after the project has ended and it has brought in change to the beneficiary plus others who are around them. So when you say effect of X on Y, so if your title reads effect of X on Y, then it means your design will be quasi-experimental. So whether even if you are using mixed method, it will have a quantitative experimental and a qualitative. So the word effect of, impact of, effectiveness of, most of the time those will be experimental. Effectiveness of can also be an ex post factor, but based on the problem. Remember, we said with ex post factor, it is after the fact. So you are going backwards. You are going backwards to find out what may have brought in the change. So that one is important to note. So we have said that the difference between true and quasi is the concept of randomization. It is the concept of randomization. And when we talk about random selection, it means every member of the population has an equal chance of being selected to be a member of either experimental or control. That means you are a member of the sample. Random selection means every member of the population has an equal chance of being selected to be a member of the sample. And then random assignment means that every individual who is participating in the experiment has an equal chance of being assigned to either experimental or control. And we have also said randomization, random assignment ensures that the groups are as equivalent as possible. The groups are as equivalent as possible. So there is no hard picking. There is no hard picking that you move to here. It is random assignment. So anyone can go to the control, anyone can go to the experimental group. So before we look at the key elements to note in experimental design, let me see whether there could be any question. Leslie is saying hi. Ibrahim is also saying hi. Thank you. Magda is saying thank you. I appreciate. Julius is saying hi. How can I get a hard copy of the research book? Please, we no longer produce hard copies. So get the ebook from the website kindly. Get the ebook from the website. Okay. Key elements to note in experimental designs. Key elements to note in experimental design. Number one, the symbols that we use in experimental. And these ones are only used in experimental. It is O, 1, 2, 3, 4, and X. Those 5 symbols are key. Now, the odd numbers represents pre-tests. The even numbers represents post-test. Now, just in case someone may be wondering, what do we mean by this pre and post? When you're doing experimental study, because you want to show a change, then there is normally a test before and then after. There is a test before and after. So the before one is called pre, the after one is called post. If I give the same example of soda causes weight gain, so I have women of between 50 and 60 years weighing 50 kilograms. So I take a pre-test first. Then my one group, I give them soda from 1st of August to 31st of August. The others do not take soda at all. And remember, I have removed all other extraneous variables. Then after 31st, I will do a post-test. So I will check whether there has been a change in weight in the 2 groups. And that is where I was saying, even if there is a change in 1 kilo, then now you can confidently say that please stop taking soda because soda causes weight gain. So note, so we have O, 1, 2, 3, 4, and then we have X. Now, the odd numbers, that is 1 and 3, represents pre-tests. And then the even numbers, 2 and 4, represents the post-test. Then the lower numbers, 1 and 2, are for the experimental design. And the higher numbers, 3 and 4, they are for the control group. So when you talk about O1, O1 is the pre-test administered to experimental. O3 is the pre-test administered to control group. Then O2 is the post-test given to the experimental. O4 is the post-test administered to the control. So the odd numbers represent pre-test. The even numbers represent post-test. The lower numbers represents experimental group. The higher numbers represents control group. And then X symbolizes treatment or the intervention that is given to the experimental group. Another element to note is the word manipulation. To manipulate is to change, and this change is deliberately manipulated by the researcher for them to see the change that it will bring on the Y, on the outcome, on the dependent variable. So it is deliberate. It is deliberate. So this change is deliberate. Like we said, when the doctors want to determine the effects of a vaccine, they are the ones who will deliberately inject the new vaccine into the bodies of those who are participating in the study. Then the others who are not participating will be given a placebo, and then they measure the change. They see the effect at the end of it all. So manipulation is another element that is key. Number 3, randomization. I think this now we have talked about many times. Random selection and assignment. Number 4 is to control. And we said to control is to remove as much as possible the effects of extraneous variable. And why do we remove them? Because they will threaten the validity of the experimental design. And I want you to note something. Anytime you talk about the word internal and external validity, those ones are not for the instruments, and we'll be discussing them next time we meet. They are not for instruments. There is validity. The word validity, usefulness, and we'll talk about it. Validity is usefulness of the inferences that you get from an instrument or from the product of an instrument, usefulness. When we talk about internal and external, they are for experimental design, internal and external validity. Those ones are for experimental. That means what may threaten your confidence to say that X cost Y. What may threaten you from confidently telling people X causes Y. That is what we mean by internal and external validity. And we'll be differentiating between the two. We will define the two and explain. So controlling in research, in experimental, is key. You must remove any factor that may confound your decision to say that X causes Y. That is what we mean by control, so that the internal and external validity of the experimental design is not threatened. In other words, your confidence of saying that X caused Y is not threatened, and we'll discuss it more. So now we look at the experimental procedures. And they are normally classified into three. Normally, we talk about the two because they are the key ones, but we have a pre-experimental, then we have quasi, and we have true. Pre-experimental, then we have quasi, and we have true. So we have earlier said that quasi, you are not able to randomly select and assign because you deal with already existing groups. When you go to a school, when you go to groups, you find them already formed. So you are not the one who is going to handpick them or select them to put them in the groups. You are not the one who is going to do that. They have already formed themselves. So the youth who have been given the Youth Development Fund, they have already formed themselves and they are already doing something. So I will go when they have already formed the groups. So I don't know how they selected themselves. So I don't know what they did. So mine will be to compare the group that was given money against the group that was not given the money. That is quasi-experimental. And as we began, we had said, why do many students feel like this is not a design that they should use? The issue is normally because of controlling extraneous variables. You imagine that you cannot, but it is something that is doable. It is something that is doable. Now you know, you only need to identify from the problem that you have, identify the factors that are likely to confound. You remove them as much as possible. We also must be at the back of our mind, we know there is no time you would say you have removed 100%. Because you know you are not sitting in the same room sleeping together for the period of time you are doing. Probably they are sneaking and doing something, but you try as much as possible to remove the effects of extraneous variables. So quasi-experimental, there is no randomization. True experimental, there is randomization. So true, there must be randomization. Something else that I may want to mention before we look at the procedures is that when you're doing quasi-experimental, and I'm using quasi because my imagination is that many of us here may be social science, you can study the same group before and after. Of course, removing the variables is a must, but you can study them before and after. The same group, and that is one way of also controlling for extraneous variables. So what do I mean by that? So I want to study the effect of Youth Development Fund on the young people who are given the fund. That is what I want to do. So instead of having two groups, one that was given, the other one who were not given, I can study the same group that was given, but now it is like I am breaking them into two. I want to study them before. How was life before? What were you doing? Based on my question, and then after, so that you can now see, has there been a change that has been brought about by this fund that they have been given? So that is also another way you can conduct quasi-experimental. It is the same, another way that you can study. So I hope you can see it is not something that is out of this world. It is something doable. But of course, don't force a design if your problem does not fit the design, because we know it is the problem that determines the design that you are going to use. And that also determines the title of your work. So pre-experimental design. Now, with the pre-experimental, the researcher studies a single group and provides an intervention. So here, why is it called pre-experimental? Because we don't have a control group. We only have one group, and the design is called one group pre-test, post-test design. So the design includes a pre-test, then followed by the treatment, and then a post-test. And this is what mainly happens in our training sessions, in our training sessions. So what happens? You are being trained on financial independence. So you have been called as a group. Many a times we go for training, you are being asked, what are your expectations? What do you want to achieve after this? It's a pre-test. It is a pre-test. Then they train you. And then at the end of it, they ask you, were your expectations met? What was good? How can we improve? They are doing a post-test. They are doing a post-test. So they did a pre-test on you. Then they gave you the intervention, which is training, and then they do a post-test so that they know whether there has been a change. So that is the one that is called a pre-experimental, because it lacks a control group. It lacks a control group. All of us in the training are going through the same intervention. So there is no group that will be compared with. We will be compared our own. It will be us before and after, like the example that I have given. You can do the same to this group that was given money. Look at them before and after, only that you're not the one who assigned the groups. Quasi-experimental. And again, there are quite a number of designs. Again, I have done quite a number of them. I think about 5 of them for quasi and the other one. But what I have done, I have picked the most common one that we normally talk about. So pre-test and post-test control group design for quasi. So you can see there is no R. There is no R. So this is the most popular quasi-experimental design, where you have 2 groups that have not been randomly assigned. You give the 2 groups a pre-test, and then you give them a post-test when the experimental group receives treatment. So you can see, we said the lower numbers will represent the experimental group. The higher numbers will represent the control group. Then the odd numbers represent post-test. The even numbers represent post-test. So you are giving a post-test to group A. Group A is the experimental group. Group B is the control group. So you give them a pre-test before. So you have measured group A and B, that is O1 and O3. And then once you measure you do the pre-test, the group A is given an intervention, that is the X. You give them an intervention, and then group B, you don't give them. You give them a placebo, something that is similar to the X. But remember, nobody should know that they are either in the experimental or in the control group. Then after your time, then you give them a post-test. That will be O2 and O4. And you compare the two to ascertain the changes that the intervention X brought. And a similar one is at the true experimental. Again, pre-test, post-test control group design. The same, only that now these groups have been randomly assigned. That is why there is capital R before O1 and O3, because you have randomly assigned, randomly selected them. So we said with true, there must be random assignment, random selection, and random assignment. So the same one, a similar one to the one at the quasi-experimental, only that now this one, there is randomization. So again, you have 2 groups. The experimental receives the treatment. You first do a pre-test before O1, O3. You do a pre-test, and then experimental is given the treatment, and then you do a post-test, which is O2 and O4. So we have talked about threats to validity. So these are threats to the confidence of saying that X causes Y. And we have said, if you do not remove these threats by controlling extraneous variables, then you have no confidence in saying that X causes Y. It threatens the internal and external validity of the design. In other words, we are saying, if you cannot control for the threats, then you are, it's like you're shaking the confidence of the experimental design. So this is what we call internal and external validity. And there are quite a number of ways in which you remove the threats. And that is what we shall be discussing in our next lesson. So this brings us to the end of our quantitative design. So lesson 7 and 8 has covered the non-experimental design, lesson 7, and experimental designs, lesson 8. So the only thing before we look at qualitative design will be to look at the threats, then we move to qualitative designs, then we move to mixed method designs, so that we discuss the two. So get the copy of research books from the website, researchmethodsclass.com. And again, you can take the free lessons on YouTube. My YouTube channel is at research methods class research methods class. So I'm sure you easily get more information from that. So before we close, let me check any question. I think I had gone up to Julius. Julius, I answered, and the same question is being asked by Hussein. Kindly go to the website. I have put the website, Hassan and Julius, researchmethodsclass.com ebook, and you'll be able to get the ebook. Mercy says, hi, Prof. Just joined. Thank you for this lecture. Thank you very much. George Wekesa, ebook can easily be done on the website. I acquired a copy yesterday. Oh, thank you very much. When will chapter 1 be reviewed? I just joined today as my first class. George, we have done, this is our 8th lesson, but luckily all of them are on YouTube. And we are moving systematically, so to say. So we are now looking at the designs, then we'll move to sampling, then we'll move to instruments, then we'll move to data analysis by God's grace, and then we shall now look at, I want to believe when you say chapter 1, it is to look at the components of chapter 1 of the research proposal. So that one we shall do in due course later on as we move along. Cassia says, thank you, Prof. Can you use the pre-experimental design in health promotion survey to identify the gap, then provide health promotion intervention of interest and do a post-test headline survey? Yes, it is possible. But if you are the one who is giving the intervention, my suggestion, though this is something that you can discuss with your supervisor, would be to use the pre-test, post-test, so that you have a group. Because mainly in health, it would be good to compare. Unless you are in social sciences, where mainly we use the pre-experimental. In health, because of the many challenges that may affect the population, it is good to have a group who gets the placebo and a group who gives the intervention, instead of using one group. But again, it is something doable, and you can discuss with your supervisor. If you feel it is something that would give you the results that you need, you can have one group, maybe give them placebo for a period of time, maybe 3 months, then you bring in the intervention again, see how it will affect them. It is still doable. So I believe it is something that you can discuss. What design can best fit this title, understanding the link between learners' attitude towards mathematics and achievement? This is somebody calling a hidden mathematical genius within revealed. All right. Sometimes when we are doing research, and this is something that many students make a mistake, we think so much about the title without thinking about the problem. Designs are determined by the problem, because it is from the problem that we get the title. We get the title from the problem. So Any title you write, it is good English. It sounds good. And I would tell you, like, what my supervisor at Masters used to say, it is just like a newspaper headline. You know, it sounds good, but the issue is there a problem? So let me assume you have a problem. By just reading, of course, we can't have a title saying understanding, because understanding is not measurable. But just looking at your title the way it is, maybe let me just show it so that the others can see. This is the question: understanding the link between learners' attitude towards mathematics and achievement. Just reading the way it is, that would be survey. That would just be survey. But note, understanding is not a measurable term. So you cannot study understanding. And then I am asking myself, what will be the variables of the study? Learners' attitude towards mathematics and achievement. So when you say mathematics and achievement, what are the variables of the study here? But of course, I know maybe you are still at the initial stages of thinking through what you are going to do. So it is still, you are still at a good point. And I believe if it is the work that you are doing, you will be well guided by your supervisor. But those are the key points that I would note from there. Kobe says, I bought the ebook and it really helped me. Thank you very much. During my research methods class, sorry about that. I beseech every student to grab a copy. Thank you, Kobe, for that comment. I appreciate so much. So please get a copy of the research methods book. And if you have not subscribed to my YouTube channel, please make sure that you subscribe to the channel. And you can also support. This work, this bringing the class. It is possible to do that through the website. But I appreciate your support this far. And thank you so much for supporting me with your words of encouragement when I've lost my sister-in-law. Thank you very much. So until the second week of August, that is when we'll have our class to discuss threats to internal and external validity. God bless you and see you then.